People are still joining. I see participant numbers increasing quite quickly. I'll give just 1 or 2 1 minute till, and then I'll give your introduction, Angela.
Sounds great. You can definitely keep that short as well, so we have some time for questions.
Well, you should have won fewer awards because that makes your introduction so long.
No, I can't keep that short. Got to go through all the awards.
Yeah.
Okay, well, why don't we get started? So welcome back, everybody, to our Robotics and Autonomous Systems breakout session at ISITA. And it's a great pleasure to introduce our third panel speaker, Professor Angela Scholig. She's an associate professor at the University of Toronto in the University of Toronto Institute for Aerospace Studies, UTIAS. And she's also a member of the Vector Institute for AI in Toronto. She's a Canada Research Chair, Tier 2 in Machine Learning for Robotics and Control, and a Canada CFAR Chair in AI. And I know how hard those are to get, so congratulations, Angela. She's part of the Canada Robotics Network and the Robotics Institute at the University of Toronto. Angela works in robotics and control and machine learning. She does a lot of work with different types of robots. In particular, she's done a lot of work with drones, and she's one of the kind of architects of learning-based control. Again, thinking about how to use model-based methods and machine learning-based methods to drive high performance but safe robotic systems. Her research team won the 2018, 2019, and 2020 GM North American SAE Auto Drive Challenge. She's been awarded a number of awards, including a Humboldt Professor in 2020, the RSS Robotics Science and Systems Early Career Spotlight Award in 2019. She won a Sloan Fellowship in 2017, and also in 2017, she was one of the MIT TR35 awardees. So congratulations and welcome, Angela.
Thank you so much for the introduction. Welcome, everybody. Can you hear me okay and see the slides?
Yes.
Yeah. It's really a true honor to be part of this event with these amazing speakers. You've already heard my affiliations are twofold in engineering and more machine learning. So I'm also part of the Vector Institute, which is a federal effort to bring researchers in machine learning together. So the title of my talk is Robots for a Better World, which is the motto of our Robotics Institute. And I hope I can allude a bit how I see robotics transforming our future. But let me start by showing you what robotics research in our lab looks like. And we filmed that just before the pandemic started. I hope it started. Yeah, so this is our building. We aim for safety and performance in robotics. We develop algorithms for teams of robots, and you see them coordinating their motion. They also can, interact with each other and build different kind of patterns. But they have become so capable that we can take them out of the lab. And so this is a test in a mock-up nuclear power plant. Here you see our vehicle fly outdoors based on vision to avoid reliance on GPS. And this could be important for delivery tasks. We fly in winds up to 28 kilometers per hour. And we also fly in mines, drive off-road, and as you see shortly on the road. So this was in Emis City, a test city for self-driving during the second competition year of our self-driving car competition. And so this car is built mainly by undergrads. And so most recently, we have also looked at mobile manipulation. So what is all this excitement in robotics about? Why are we having these sessions? So we believe that we can make the leap from applications in dedicated structured environments to more complex environments and tasks. And you have seen lots of amazing examples by the previous speakers. And so these robots leave the industrial setting and become increasingly mobile, adaptive, and interactive. And you see here some home applications, but also robots interacting with humans and exoskeletons. So this trend is really driven by a few key enablers, and some, are related to ECE because they were really due to the smartphone revolution. So we have inexpensive lightweight sensors, increasingly powerful and distributed compute, high bandwidth, low latency communications, and as a result, access to increasing amounts of data, which we can make sense of by leveraging some of the representational and algorithmic advances in modern machine learning. And finally, we as researchers, but also companies, have gotten better and better at making their software tools available, sharing them broadly, and also sharing the data sets. And so if we look at the robotics pipeline, it really means that there's amazing technology that we can leverage to build robots operating in the real world. But this requires the integration of hardware and software and data, and the integration of first principles and physics with data. And so I feel this integration, we are still, I think, just doing a few baby steps in terms of what technology is really available. But it is an opportunity for ECE departments because, hardware and software and integration is really core to electrical and computer engineering. And a key to using these kind of enabling technologies, in my own opinion, and to really build capable robots is to dissolve some boundaries between engineering and computer science. And I don't want to kind of argue about the definitions of some terms, but if you think about artificial intelligence in terms of software that automatically performs complex virtual tasks and is often driven by computer scientists, then robotics, is programmable hardware that automatically performs relatively simple physical tasks. And if we kind of, work at the intersection, then robots can really become capable, sense the environment, make decisions, learn to perform complex tasks. And let me give you one very specific example that relates to my research. So computer science has made immense progress in terms of, expressive machine learning models and using them to extract information from images, which you see at the top. And so really machine learning is the state of the art and can do that better than anything else, any technique that we can think of. And so image understanding is extremely important for self-driving. And so we want to use these tools in robotics, but then we use them in a feedback loop. We actually do physical actions based on these machine learning components. And these physical actions reinforce what we see in the next time step. And so, interlacing machine learning components with control theory is really important. And understanding the complexity of these systems and analyzing their safety is important to build robots for the real world. But if we combine them well, we can do amazing feats. And I just show a few examples from my research. So here the robot learns from experience a task that we could not do with traditional methods. So it learns on top of those poles, a slalom motion that is fast and really hits the limits of the capabilities of that robot. And so here you see the robot performing this task. You can do other slalom configurations. And this is what it looked like based on our prior understanding of the system alone. So this was not sufficient for this task. We have similar examples where simple learning from a few minutes of flight to refine the model of the robot, gives us improvements in tracking error of 40 to 50%. And one fun recent example is we tried to catch balls with a mobile manipulator. And here machine learning helped us to improve the success rate by 20%. And so to show you how difficult this task is and how machine learning can really push the performance of robots. Here you see a few throws, and this is all real time. And we really need the temporal and spatial accuracy. And there's failures. We have not a 100% success rate. And so here we predicted the ball trajectory not well enough. And so here we didn't track the trajectory of the robot well enough. So these are some examples where we combine, data and machine learning with control theory to achieve high performance robots that work reliably and better than what we could do with traditional methods. But thinking about robotics is much more than just marrying computer science and engineering, in my opinion. So this is an overview of who's involved in our Robotics Institute. There are over 170 members from 14 divisions, and there were 8 new hires recently across 4 divisions. So that was in the last 5 years. And while engineering and computer science is really dominating the membership, we have members from medicine and architecture and other fields. So why are they interested in robotics? So I think I only showed you half of this picture, and I really want you to remember the other part as well. While there's a lot of enabling technologies that make us, enable us to build amazing robot systems, robotics itself is an enabler for a lot of application areas that have a big societal impact, such as health, mobility, and manufacturing. And so in the next decade, I think there's a lot of innovation happening on this second arc. And so, yeah, if you remember one thing from my talk, I hope it's this image to see, how robotics on the one hand draws from a lot of enabling technologies, but then enables up really impactful applications. And so one example is this. So one of my colleagues works on, Jessica Bruckner-Kars, she works on continuum robots. And so she envisions them to work for both like aerospace inspection, but also for surgery. So it's an enabling robotics technology that really kind of has an impact in different application areas. And what that also means is you can be an amazing robotics researcher here, here, and here. And sometimes this last part is taken for granted, but it's actually quite difficult, right? It requires collaboration, communication across boundaries, thinking about the real societal needs. And like from an academic perspective, it means publishing in unusual venues. And so I have done a few of these translational projects in health and mining, and 2 of those papers are in my top 10 cited papers now. So they can really have an impact also on the academic side. So yeah, really the question is, which field do we transform next in terms of societal applications? I also want to spend a few minutes talking about education. This is basically the same image you see: enabling technologies, robotic systems expertise, the future of health, etc. If you think about education, really the fundamentals are math, physics, and dynamics are really required to transform enabling technologies into robotic systems. And I think this field is moving so quickly and is driven by so many different enablers that a good background is just the only way you can keep up and understand and shape the future of robotics. But then I also really see the impact that hands-on skills have. And I think we have seen this in the previous talks, like from programming and software tools to really hands-on robotics troubleshooting. I want to just briefly bring up this example, which had a much bigger impact than I envisioned when I got involved in this. So this is 60 undergrad students and around 10-15 grad students building a self-driving car from scratch for this SAE General Motors Auto Drive Challenge, which we have now won 4 times. We just heard that we won the last competition yesterday or 2 days ago. And so these students have amazing skills. Like, it's also impressive with much lower budget than typical self-driving car companies. We built a car that's pretty capable at this point. And yeah, the students are very hireable. They usually go to the top players in self-driving after they graduate. And yeah, you know, the success is really based on their strong foundations, but also their way of working across boundaries and collaborating really effectively. And so finally, I think something that was alluded to before in some of the questions and talks is there are other, you know, skills that are really powerful in robotics, especially if you think about the societal scale applications. And so you're currently in the process of developing a robotics leadership program that for graduate students that teaches some of that. But no matter what, these students will really, you know, have a big impact and will be the change we are all looking for. And they will have an impact because if you look at recent job reports, this is from 2016 to 19, robotics was growing in terms of job offers 40% each year. And in the United States, it's the second highest, fastest growing job area. Canada is not that great, which we have to work on. So for us, it's number 10. Yeah, so it's really exciting to see that these students learn skills that are really sought after in industry now as well. And so finally, yeah, I hope you remember this pipeline and that robotics is driven by enabling technologies, but is an enabler itself for a lot of important applications. Thanks. And thanks to the Robotics Institute as well. Yeah.
Thank you, Angela, for that fantastic talk and those perspectives on you know, research and the pipeline and also education. As we're now thinking of questions for Angela and moving into our discussion, I might have something quite specific to ask you, which kind of leads off from your education slide about math, physics, and dynamics. You know, at Berkeley, we're one of the few EECS departments, so we admit as a department, and we've been trying to address the challenge over the past decade of students choosing CS in their entry level freshman first year, because they're immediately, you know, doing exciting projects and going into getting internships at kind of software, you know, positions in the summer. And so we're trying to think about how to you know, attract students as they come in and you know, get them to feel how important the math, the physics, and dynamics are, so that they become not just AI specialists, but robotics engineers as well. I feel that that is really key in training a robotics engineer, as you do. What are your thoughts about that? What maybe your thoughts and maybe what you're doing in the undergraduate program in Toronto?
Yeah, this is a great question. I guess we have a special case in Toronto because we have this kind of elite program called Engineering Science, which is recruiting students that want to learn these fundamentals. And the first 2 years are general engineering and focus on fundamentals only. And then they can focus on, for example, robotics in their 3rd and 4th year. And so they come into this program with the knowledge that it's very math heavy. I think, yeah, it's a really good question. Some of it is also, you know, I think AI sometimes tries to say we can do everything from data, but in fact, if you look at this, these people are experts in the kind of application areas they work on, and there's a lot of intuition and understanding and first principles going into these models. And a lot of these people are not computer scientists, but you know, electrical engineers who design these new network structures, for example, in machine learning. So I think some of it is kind of telling the right story. Yeah. And for me personally, you know, basically, my experience was if I don't understand a certain concept, it's because I don't understand the math. really the fundamentals of whatever math they are using, probability or something else. So I think it's really limiting what they can do in the future. But it's hard to communicate. Yeah.
Thank you. So now we'd like to open up, and Magnus, your thoughts as well. We have 15 minutes, and we have two of our panelists, Angela and Ken, here. We want to return to some of the discussions we were having before the break about diversity, because we were cut off on that. But Magnus, why don't you take over and kind of give a lead in how you'd like to run this next bit.
Yeah, thank you, Claire. So we decided that Claire was going to deal with the first part and I was going to deal with the second part. And I'm happy to report that the second part has been shrinking steadily. So thank you for that, Claire. We've seen 3 outstanding presentations. And well, let's just open it up. Let's have a free-form conversation about issues we would like to discuss. And step 1 is, Ken, you were talking about Black in Robotics and the Black in AI initiatives, and then we ended. So I would like to return to that cliffhanger and uncliffhang us, if you will.
Sure. Because I think that we're using this as an example to really start thinking about diversity much more broadly, to include certainly women, Hispanic, persons with disabilities. There's so many groups that haven't been as active, say, in these programs, and we want to try and understand why and how to bring them in. I really think that the interest is there. There's been barriers, though, very subtle ones, like, for example, the GRE. We found out through lots of discussion. I think many departments are having that debate right now, but the GRE was discriminatory. Yep. And we heard this from our Black students and faculty, and then there's a big debate about it, but we came to the conclusion that it was, and that we were going to eliminate it, not just make it optional, by the way. And I think there's other examples of that. That, for example, was a huge issue especially for African students, because the cost was very high. $200 is a lot, and also that it's only given in major cities, so oftentimes it wasn't an option for them. So we were thrilled that we had an unprecedented number of applicants from Africa, and we were also able to really spend time on looking at their applications carefully and admitting many students more. So now they're coming, and now the next part is to make sure that they are that they are comfortable, that they are thriving, supported, and to keep bringing in future generations. We don't want this to be a one-time thing. I think that's another danger, right? We all get enthusiastic and then we kind of move on. That's so important to sustain that interest. But I feel like we have opportunity to really diversify across the board. And I think we've made a huge amount of progress in terms of women. I see 3, exemplars right here in front of me. And Rujana, by the way, I'm happy to see her because she was a huge inspiration for me when I was an undergrad, going back to Penn. She got me interested in robotics. And Claire and Angela, I mean, there are so many incredibly successful and powerful women now in the field. And so what else can we do to build on that?
I think the GRE is a really good point, where what seems like a small tweak really has profound effect. So we also got rid of it altogether. And by far, in fact, we're 140% more diverse, our incoming PhD class this fall, than we've ever been before. I mean, when it comes to URMs, it's remarkable. And I think it can be traced directly back to the GREs. I think so. Personally, I think that's a thing of the past. And it seems like such a small change, and it has dramatic impact. Yeah, Angela, I was going to ask you, and in fact, feel free to utilize the chat if you have questions, or raise your hand, or just speak up. I think all of those forms are equally acceptable. But Angela, I was going to ask you, so at Georgia Tech, we rolled out, first we started with a PhD program in robotics, and you got a PhD in robotics, not in ME with robotics. And we were really nervous about, this kind of boutique type degree, or employers going to care, or our students going to want to have it. And we saw across the board that there was excitement for this. Do you think it's time to start having, robotics departments and get rid of and not just minors or certificates, but actually go all in? And that's my question.
Yeah. We also surveyed our students who currently work in robotics but are associated with different other departments, and like 95% would rather have a robotics degree. So I think some of the question is, will this last? Like, will robotics stick around, or is this a current trend and we will go back, it will be there for 10 years and then the excitement is less, so it has moved into different fields and we don't need it. I do think it will last. And so I hope, no matter how it is organized, that these kind of cross-departmental and cross-faculty connections happen, right? That even if we have those boundaries in terms of the departments, that we somehow cross that through institutes or other efforts. I think that's the important part. Yeah.
Any other?
Ruzhina, you were shaking your head in response to that. So Ruzhina, please unmute yourself and comment. You're muted, Ruzhina.
I think, Magnus, I really object to have a school of robotics or a degree. In fact, even degree is dangerous. What I really think is that education has to be sought extremely stratified yet diverse, because we are not all the same. We are tall, short, fat, white, black. So we are different. And there, in a scientific world, there has to be space for people who are interested just, in mathematical games and are not interested in money. There are other people who are very commercially oriented, and their objective in life is to make business and money. So there has to be a space for all these diverse people, so that different young people, and some of you may have grandchildren, I have them too, or great grandchildren, and you can see the different orientation and how some are going towards more what you would call the discovery-based studies, and some others are interested in engineering development and don't care whether it's a new idea, but it works. So I think the future should be very open to diversity in the context. Can explain the diversity. It's right now more from where you are born and origin, but there has to be diversity in your aspirations, in your interests.
If I could just add to that, I think I agree with Ruzhina. I think one danger, though, is that we offer so many courses and there's such a breadth of new topics that we get breadth rather than depth. And that's to be guarded against. I think that I still am very proud that I'm a double E major, that I had to take all those fundamental courses. And I think that that's really important, that you need a deep grounding in one of the disciplines. So I think that, for example, I like the idea that it's not just a generic robotics major or discipline, but there's specialists who are mechanical engineers, electrical engineers, computer scientists, industrial engineers, all of whom have, let's say, a minor in robotics, and they all learn how to work together.
Thank you, Ken.
This also goes, we also had this discussion and basically saying, departments is about backgrounds, and these more cross-departmental institutes is about working on the same problems, right? And it's kind of a difference, and that you can see. And so being grounded in one area, I can definitely see how, how this is important, but should not limit you in terms of aspirations for collaboration.
So personally, I actually think there is one even stronger thing you can say about departments, that really what they describe is historical artifacts more than anything else, that the way we're organized reflects history more than anything particularly intellectually interesting, in my rather humble opinion. But moving on, so Miguel has an interesting question about kind of GRE++ here. So Miguel, would you mind stating that so that we hear more voices?
Yes, I just have a question that kind of follow on what was discussed on the GRE previously. There is I have a personal concern about students coming from, in general, socioeconomically disadvantaged backgrounds in the U.S. Particularly, of all races, ethnicities. So it's not only for underrepresented populations, and access to education, which seems to be very challenging for some of them. And and I see that we are particularly, just to give an example, many top-tier universities do not count coursework from community college, but most of the students coming from socioeconomically background because of finance, they start their careers in community college. So if we want them to gain access to education and education in these areas, how can we overcome those barriers in a way?
Yeah, maybe I'll just have a comment on the second point, Miguel, because Berkeley does have a recognition of the coursework from community colleges. And we have a very, I think it's a very good community college transfer program into our engineering, in particular into EECS. But it's still a challenge. And one of the things that we've been thinking of as a department is how to develop summer programs for students in community colleges to make them aware, like to bring them to campus, make them aware, not only give them a little bit of research opportunity as an undergrad, but also make them aware of the transfer program and give them some courses to help them as they transfer. So, they may have this course equivalent, but it's not the same as the Berkeley version, for example. So what are the topics that we do in a summer program to be able to get them ready for the Berkeley version of the next course for which that was a prerequisite. I believe that's really important. And at Berkeley, it's been a very big success in increasing our population of underrepresented students.
And if I may jump in, I think what you bring up is also really important, Claire, about this kind of almost bridge program. So I'm going to go even further into high school. So Georgia Tech, we're smack in the middle of Atlanta. This is a majority minority city. We have the Atlanta public schools around us, which is majority African American, but the boundary between the city of Atlanta and Georgia Tech campus is rather stark. I mean, people on campus don't necessarily look like the rest of the city. I'm just going to put it that way. And this is a problem we have. So we've been very, very aggressive. We go out in the high schools and we talk about Georgia Tech. We give people exposure and opportunities. And then, oh, by the way, if you don't have AP Calculus, you're not getting into Georgia Tech. And now we're talking to juniors and seniors. If they all of a sudden say, come to Georgia Tech, but if they're not on an AP Calc track, they're not going to come to Georgia Tech. So this is now where we either go earlier or add things. So Ken, go for it.
So Magnus, I'm so glad we're talking about this. One interesting thing, I know there was a study I saw years ago that in terms of socioeconomic diversity, that engineering is actually has very rich diversity in that way. Many engineers come from our first generation, right? And part of it is that they're just tenacious because they have to do all this very hard work, and so they are not comfortable in any way. So they want, they're willing to really tough it out through these hard courses. So I think, but one thing we can do, I think, is to tell our stories. I mean, I grew up in a family that struggled financially, and and it was hard. We didn't go on vacations. We didn't get steak dinners for we couldn't afford that. So one of the things I think is, like, how can we be examples? And to your point, we're just at the point now where my daughter in 6th grade had to pass a test to decide if she's going to go on to advanced math, right? And that's 6th grade. It turns out that if she doesn't get into that class, then she's not going to be in the advanced class, which is going to percolate all the way up to her advanced AP Calc. She won't be able to take that. This is decided at the end of 6th grade.
Yeah, that's crazy.
Yeah.
So what we have done is very similar to what Claire described, which is we've actually gone to the registrar and the admissions people and said, you know what, we're willing to make an experiment, but we're going to provide these extra courses and extra resources for these really smart kids that just don't happen to have AP Calc. And we've kind of stuck our neck out a little bit, but we're willing to test it to see, and we want to be able to point to it and say, look, yeah, AP Calc is really good, but you shouldn't be forever banned from coming to Georgia Tech if you don't have it, or to UC Berkeley or wherever, MIT, Toronto.
It's a lot more than that, though. I mean, just talking with some of the student groups, it's not just getting in and getting those courses, those background. There's so much competitiveness, like just to belong to our undergraduate student groups, the machine learning group, the UAV group. To get in, you have to show your resume. There's so much competition that's kind of, there's more that we have to do, and I don't know the answers right now,
but you do have 20 seconds to wrap things up. So do you want to end on a...
Let's end on a high note. How about you end then, Magnus?
This was really, really fun. And thank you all for attending. I thought it was vibrant. I thought it was exciting. And I am going to give you 3 seconds of your lives back.